to position starting from acceleration. So to get to velocity first, we will integrate acceleration, and we will start by putting down the initial velocity and then adding the integration of acceleration. We'll write the acceleration as a fraction, and I will use a dummy variable because when we use this technique, we have the t variable in one of the limits of integration. Then we will do our integration. The constant will float to the front. We integrate the variable part. That will be x squared over 2. And then the evaluation is from 0 to t. Plugging in 0 into the antiderivative will give 0. And when we plug in t, we will end up with this. So there is the velocity function. To get to the position function, we will take the initial position, which is 0, and then we will add the integral of the velocity from 0 to t. And once again, we will use a dummy variable inside the integral. So I'll use x again, and that will be what we need to integrate to get to position. So the integral of 5 is 5x, and then over here we can leave the constant in front and integrate the x squared, giving x cubed over 3, and this will be evaluated from 0 to t. The antiderivative evaluated at 0 is 0, so we just have to focus on substituting a t in for the x, and our denominator here becomes 600. We will have x cubed, but when we replace the x with a t, we will end up with a t cubed, and that is it. That will be our position function as a function of t.